So in the previous video, we learned about how to take a graph of sine or cosine and to turn it into an equation of sine or cosine. So now let's go ahead and learn the reverse of that. So we're still dealing with sine and cosine transformations, but now we're going from an equation to a graph, whereas in the previous video, we went from a graph to an equation. So for the sake of time, I'm going to go ahead and not show the equations that I showed at the beginning of the previous video. So if you haven't gotten a chance to look at the previous video, just go ahead and take a pause, look at the first couple of minutes of the video, just so that you understand all the different parts of the equation of sine or cosine, and I don't have to go through that all here. So let's go ahead and take a look at the first one. Let's jump straight into it. Here we've got an equation y equals this 2 times the sine of x. So what I'm going to do is I'm going to list off the relevant information here. First thing I notice is that the graph is not reflected. So I'm going to go ahead and say no, it is not reflected. And these are just little notes for me. The next thing I'm going to look at is the amplitude. So the amplitude of my graph, well, I see here that it's 2. So I can go ahead and say that the amplitude is 2. The next letter we can look at is the period. Period would be 2 pi over b. So in case you've forgotten, the equation for your period is equal to 2 pi over b. In this case, let me go ahead and put up all those extra things. Really what's hidden inside of here is there's a lot of things that we assume. So positive 2 times the sine of 1 times x plus 0. All of these things are actually hidden inside of there. And that's where I got that it's not reflected, is because you've got a positive out front. And now we're looking at the b value. So we know that the b value is going to end up being 1. So if I plug that into here, your period is equal to 2 pi over 1, which means that our period is just 2 pi. So this has the same period as the sine and cosine graphs, their original parent functions. The last thing we would look at would be the plus or minus d, which stands for your vertical shift. In this case, we're plus 0, so we have no vertical shift. There is none. And this is all the information that's going to help me graph. First thing what I need to do is, if you look at my graphing space over here, you'll notice that there's no scale to it. So that means that I get to decide whatever scale I want. And I'm going to choose something that fits on the graph. So if I decide that each box is worth 10 units, then that means that I'm going to create this super teeny tiny graph that isn't really going to do much for the observer. It's not going to show them anything. But by that same idea, if I choose that each box is 0.001, then my graph is going to be gigantic, coming way off the graph, and it's not going to, again, show anything to the observer. So what I need to do is to discover some kind of nice scale that will work with this graph. Sometimes you might get a graph that already has a scale on it, or you might be told always make sure that each block stands for 1 unit or something. In this case, I don't have any sort of scale or legend going on here, so we can choose our own. In order to do that, I need to figure out what y scale will work the best. So the first thing I'm going to do is find my y scale. Y-axis scale. And I can do that by figuring out what is the maximum y value that I'm going to have and what's the minimum y value that I'm going to have. And those two are both by looking at the midline, the midline and the amplitude. So my maximum value that I can have for my y is going to be the midline plus the amplitude, because your amplitude is from the midline to the crest, and then your midline is going to be either shifted up or down somewhere. So the maximum value that I'm going to have on this particular graph is going to be 0, because there was no vertical shift, plus 2. So in this case, 0 plus 2 gives us a maximum value of 2. The minimum is going to be nearly the same thing, except now we're going to subtract that amplitude, because from the midline to the trough, we're going to go down. So 0 minus 2, meaning that our minimum value is negative 2. So I know that I need to find a way to make positive and negative 2 fit nicely on here. This is the range of our current equation. And just to make it easy on myself, I'm just going to go ahead and say that this right here is going to be positive 2. I'm going to change colors so that I get a nice color differential going here. We've got a positive 2 up here, which means here's 0, and I'm going to go ahead and say 2 down is negative 2. That'll give me a nice little window here. I can see here's going to be the top of my graph, here's going to be the bottom, and then I'm also going to go ahead and draw in my midline. So this is just a me personally thing. I like to put in my midline so that I know exactly where to go. I have seen students in the past go ahead and put in another little dotted line for your max and another dotted line for your min. That way you know that you don't go over those lines or under those lines. Personally, I think it looks a little bit crowded, but if it works for you, it works for you type thing in my opinion. So next thing we did was we set up the midline. And now I'm going to go ahead and graph those critical points. So I talked a little bit about critical points in the video where we looked at the parent functions of sine and cosine. And we discovered that the graph of sine at x equals 0, we're going to go ahead and start with a critical point on the midline. So right off the bat, I know that there's going to be a point right here for my graph of sine. And the next point is going to be dictated by whether there is a reflection or not. So this is going to be critical points, and this is where you have to be careful of reflections. Because if our graph is reflected, then we need to make sure that instead of going up to a crest like we normally would, we would go down to a trough. Now because we're not reflected, we're just going to follow the regular old pattern, which is midline to crest. Again, there's no scale on my my x-axis, so I'm going to go ahead and jump and say every 2 is going to be a new critical point. So 2 and go up to there. So midline crest. Now we're going to go back to the midline. And then we go to the trough, so down to the minimum, go over 2. And then it's back to the midline, and then up to the crest, and then down back to the midline. So midline, crest, midline, trough, midline, crest, midline, trough. And we could go backwards as well. And again, these are graphs of sine and cosine. We got to keep them loosey-goosey as we go through. So we're going to resist the urge to zip directly from one point to the next, and keep ourselves a nice little curve as we go through. And then at the end, because this domain is from negative infinity to positive infinity, we can go ahead and put those little arrows at the end. But if you noticed, so we've done something with reflection, done something with amplitude, and done something with vertical shift. The last thing we need to look at, if we have no scale set, is to get the x-axis scale. So I teach my kids something called, students, I call it half, add 'em up. And this was actually taught to me by another teacher that I used to work with. Half, add 'em up. So what that means is I'm going to look and see where is one full cycle. So again, one full crest, one full trough. From our x-axis to here is one full cycle. And what did we decide one full cycle was? Well, that's our period. So we know that this line right here should be 2 pi. So what I mean by half, add 'em up is I'm going to physically put my pen or pencil or whatever you're using halfway between 0 and 2 pi. So that's this right here. And this line right here is going to be half of 2 pi. So 2 pi divided by 2. Here's our first half. So half, add 'em up. Our first half is pi, which means this guy right here is pi. The second half that we're looking at is we're going to take pi and divide it by 2. And I know that seems silly because it just ends up being pi over 2, but just to help you guys with that idea. Halfway physically between 0 and pi is this line right here. And we just discovered that's going to be pi over 2. Normally a lot of people have issues figuring out what is halfway between pi and 2 pi. So this is where the add 'em up comes in handy. What I'm going to do is I'm going to take this pi value and I'm going to add it to pi over 2. I see that I'm adding a fraction and a whole number, so I need to go ahead and turn that whole number into a fraction. And then I need to make sure that I'm finding a common denominator. So I'm going to go ahead and multiply by 2 over 2. So 2 pi over 2 plus pi over 2. I find out that this value right here is going to be 3 pi over 2. And this will effectively graph that sine curve to sine of x. If I want to, I can go ahead and double check and make sure everything is correct by using this little chart right here. So first of all, it's a graph of sine. I do start at the midpoint. I am not reflected, so I know that I should go from the mid to the crest, which I do. My amplitude is 2, so here's my midline. The distance between my midline and my crest is 2. Distance between my midline and my trough is 2. So I can go ahead and put a check mark there, and a check mark for the sine. The period, the distance from here to here, which is 1 full crest and 1 full trough, is 2 pi. So I can go ahead and put a check mark there. And last but not least, vertical shift. It is currently on the x-axis, so yes. So that is the first example of how to turn an equation into a graph. I've got 3 more practice problems for you. Just like the last video, I would strongly suggest when you first see the equation, go ahead and pause it and see if you can graph it on your own before you see me explain through there. So let's take a look at that next problem. Here's the next one that we're going to look at. Y is equal to negative cosine of x plus 2. So again, we're going to start by asking ourselves, is it reflected? And the answer this time is yes. So if it helped you, I'm going to go ahead and put in all those little hidden things. And if it helps you, go ahead and do it on any sort of test or quiz. Technically, this is negative 1 times cosine of 1 times x plus 2. There are those imaginary ones there. Not quite so much imaginary, but they do exist. You just can't see them. So yes, this is reflected. The next thing that I look at is the amplitude. And the amplitude in this case is that value of 1. The next thing to look at is the period. So again, the period is equal to 2 pi over b. In this case, again, our b value is 1. So we're looking at another period of 2 pi. Last thing is our vertical shift. This time we do have a vertical shift. What I tell my students is don't put down plus 2. Don't put down plus 2 because that might not mean anything to you. The vertical shift is actually up 2. And that's what I like to do for them so that they can see, oh, I need to make sure to go up 2. It's not just positive 2, it's up 2. So again, we're going to try and figure out what scale works best for us because just like the last graph, I didn't give you guys a set scale on there. So I'm going to real quick figure out what those max and min values are. So the max, again, is going to be your midline plus your amplitude. In this case, looks like mid-tamp. Let me real quick erase that. Midline plus amplitude. There we go, a little bit better. So our midline is now at 2 plus our amplitude, which is 1. So our maximum value is 3. Our minimum value this time, again, still midline, but now it's minus the amplitude. Midline is at 2, amplitude is 1, so our minimum value is 3. So depending on what type of graph you're given or what teacher you might have or anything like that, really this is a totally blank slate. So I recognize that my graph is not going to be down here. If you were to look at it just like a regular, it's not going to be down here. All of my graph exists up here. So if I wanted to, I could go ahead and start my graph all the way down here and show just the first and second quadrants. So some of you may end up like doing that. What I'm going to do is I'm going to start my graph and I'm going to say that 0 is right here. So that way I got a lot of nice big space up here. And let's see if we can figure out, so up to 3. So we got 1, 2, 3, 4, 5, 6, 7 blocks, which means we're going to go ahead and say each block is 2. Sorry, every 2 is 1 unit. So here's positive 1, here's positive 2, and here is positive 3. So now we got a nice big old graph to go ahead and move through around here. My straight lines are not so wonderfully straight, so we're going to try and see what happens here. Actually was not too shabby. So if you'll notice, I didn't do anything in the second quadrant. Your teacher may require you to do something in the second quadrant, but really it's just going backwards. So you're following the same pattern over and over and over. So I'm going to go ahead and neglect this second quadrant here. I'm not going to do anything in the negative x-axis. So let's go ahead and look, the next thing we need to look at is the midline. So I'm going to go ahead and draw in that midline. I know that it's at y equals 2. So here is that midline. Because I'm looking at a graph of cosine, I know that I would normally start up at a crest. So midline would mean that I would start at a crest, but since I'm reflected, I have to start at a trough. So I'm going to go from my midline, and I'm going to go down to my minimum point, which is 1. The pattern for a sine is going to be crest or trough, depending on that, straight to the midline, which is right here. And then you go up to either the crest or the trough, depending on what you were at before. And you're going to still follow that same pattern. Now we're going back up to the midline, and then up to a crest, and then, oh, we would end up over there. I feel like I missed a line somewhere, but it looks like it's all even, so we're good. So now again, we need to resist that urge and connect those dots nice and loosey-goosey. Oh, that's where I messed up. So if you'll see, I didn't go over 2. So that's what happens. Oh, almost erased the whole thing. That happens every now and again. That's the beauty of an eraser here. And 1, 2, right up there. There we go. So just as a heads up, what I noticed is as I went through, I ended up having to make this down here. I had to go really, really close and make it a crazy slope in order to get to that next point. So that's how I knew something was messed up, is it wasn't following this nice wave pattern. So if you ever end up having a weird point on there, double check to make sure you didn't just skip counting or you messed up the location of something like I did just then. So again, we go on forever and ever, so we make sure we put those little arrows to state that we are going to continue on. Last thing we need to figure out is our scale for our x-axis. Again, our scale is going to be determined by the period. So starting here, we do half of a trough, a full crest, the other half of the trough. So from here at 0 all the way over to here is 1 full cycle, which means we travel 2 pi units. So over here is 2 pi. Using our half-half add 'em up method, half of that is 2 pi divided by 2, giving us pi. The other half is going to be pi over 2. And adding them up, you can rewind if you need to see how we add them up again, but it ends up with 3 pi over, not 3 pi over 2. So halfway is going to be 1, 2, 3, 4. Yeah, right here is our halfway. Halfway between there, pi over 2, and halfway there, 3 pi over 2. Again, you can check it by saying, is this a graph of cosine? Yes, we start at either a crest or a trough, so it is cosine. Is it reflected? Yes, we started at a trough instead of a crest. Is the amplitude 1? Well, from here to here is 1 unit. From here to here is 1 unit. The period from here to here is 2 pi, so awesome. And last but not least, vertical shift, we did in fact go up 2 units. So here is that one. We're going to go ahead and move on to our third one. We've got one more after this. So we're going to go a little bit quicker because I'll be honest, my voice is feeling a little bit rough right now. Let me go ahead and write in all this here. Y equals, we've got an assumed positive cosine of x over 2, and then an assumed plus 0. So a reflection, no, we are not reflected. Looking at the amplitude, we have an amplitude of 3. Looking at the period, so this is a little bit different. This is one that I want to make sure to explain a little bit better here. One thing that tends to get people is they look at this and they're not sure what their b value is. So let's go ahead and break it down and try and figure it out. And the way that I'll normally explain it is, normally we'll multiply fractions to get this, but instead of simplifying, let's go ahead and expand it. So we could expand this to 1/2 times x over 1, which is equivalent to 1/2 times x. And if that doesn't work for you, then I'll show you another little thing that you can do. If you look at it, we could turn it into that, which is a whole number divided by a fraction. And anytime you see a fraction inside of a fraction, you should think to yourself, you multiply by the reciprocal. A lot of other people know it as keep, change, flip, but I'm not a huge fan of that. That's kind of like the elementary way of saying it. The official math way is you multiply by the reciprocal. So we can think keep, change, flip, but we say multiply by the reciprocal. So if we're thinking keep, change, flip, you keep the numerator, change division to multiplication, and you flip the denominator. So you multiply by the reciprocal. Reciprocal is the math word for flip. So now we end up with x times 1/2, which is an alternate way of seeing, oh hey, the b value ends up being 1/2. So when I say that period is equal to 2 pi over b, then I end up having to say 2 pi over 1/2, which again, we've got a fraction inside of a fraction, so we multiply by the reciprocal, keep the numerator, change division to multiplication, flip the denominator, we're left with 4 pi as our period. And last but not least, we're looking at a vertical shift. Since we have plus 0 at the end, there is no vertical shift. The next thing that we got to do is figure out the scale. So now we're done collecting information. Let's go ahead and figure out our scale over here. I see that the amplitude is 3, the midline is none, so the maximum value is going to be up 3. I'm going to go ahead and say here is our 0. We're going to go up 3. So you know what? Let's just say each box is worth 1. 1, 2, 3. That means this is -1, -2, -3. So if we are graphing the cosine graph that is not reflected, we're going to, forgot to draw in my midline. For graphing a cosine that is not reflected, we have to start up at the crest. So crest to midline to trough to midline to crest to midline to trough. Resist the urge to skip blindly from one point to the next and keep it nice and loosey-goosey. Curves are getting a little bit funky here, but I'll forgive myself. So here's the new thing that people probably aren't as comfortable with, which would be finding that period. So figuring out what that x-axis scale is. Well, your period is going to be from here. Let me go ahead and put it onto the graph itself. So here's 1/2 of a crest, a full trough, the other half of the crest. Now what we discovered is that period should be 4 pi. So this right here is going to be 4 pi. Doing our half-half add 'em up method, 4 pi divided by 2 gives us 2 pi, which means halfway between it physically is right here at 2 pi. The second half is taking that 2 pi, dividing it by 2 again, and getting pi. So this right here is just pi, and then adding them together, 2 pi plus 1 pi gives us 3 pi. So it doesn't matter if you're dealing with fractions or whole numbers or with pi, half-half add them up is going to help you out figuring out that scale there. There's one more on here that kind of mixes together everything that we've looked at. So this really is the challenge problem. I know this is a long video. Thank you for sticking with me. Hopefully you guys are trying it out on your own as you're going through, but here's one more practice problem for us. This one I don't need to, oh, yeah, sorry, I do. There is one imagined item in here, or assumed thing in here, which is that 1 at the start. That is times 1 technically. So a reflection, yes, in fact, there is a reflection on this one. That's why there's the negative. Then we look at the amplitude. Amplitude here is just regular old 1. Looking at the period. So the period of this guy is going to be period equals 2 pi over b, where our b value is 2. 2 pi over 2 gives us a period of pi. Next up, we need to look at the vertical shift, which in this case is down 1. Since we've got negative 1, we're looking at down 1. Real quick, now that I see that there's a midline shift, I'm going to go ahead and figure out those maxes and mins. So the max is going to be your midline, negative 1, plus 1, so our maximum value is 0. And this time our minimum value is going to be our midline minus our amplitude, so negative 2. This is another case where I could, if I really wanted to, ignore these top 2 quadrants and just deal with these quadrants down here, because I see that it's never going to go into that first or second quadrant. I'm going to go ahead and set my graph just arbitrarily. I'm going to set my 0 line here. That means that I give myself a nice big space down here to work with, and then I give myself a lot of space all off to the side here. If I want 0, so my max is already right up here, my minimum is going to be at 2, and I think I've got enough space where I can go ahead and set each box is worth 3. So I'm going to say 1, 2, 3, sorry, 1, 2, 3, here's 1, sorry, negative 1, and here's 1, 2, 3, here's negative 2. Good, I got myself a nice big old graph here. So we've got our scale there. Let's go ahead and put in our midline at negative 1. And then we need to put in our dots. Since we're looking at a graph of sine, we know we start at the midline. It doesn't matter if you're reflected or not, you start at the midline for a graph of sine. So a reflected sine graph is going to go down to a trough next. So midline down to trough, midline crest, midline trough, midline crest. It's still following that same pattern. So the only difference here when you're dealing, the only difference here when you're dealing with that graph of sine reflected is you're still starting at the midline. Reflection is going to change all crests to troughs and all troughs to crests. So here is that last one. We figured out that. Last thing to do is figure out the period, so the y-axis scale here. Well, one full period is going to be a full trough, a full crest. This right here is the cycle, which means this line right here, I'm going to put it in green, that line right there is going to be our period, which is pi. Using the half-half add them up, the first half is pi over 2, which just equates to pi over 2. Again, I feel kind of silly writing that, but hey, sometimes you got to write it down. The second half we're looking at is pi over 2 divided by 2. Again, we see a multiply by the reciprocal situation. You take that numerator, change division to multiplication, and flip the denominator. Technically, that's 2 over 1, so flipping the denominator makes it 1 over 2. Pi over 4 is my second half, so this right here is pi over 4. When I add them, it's pi over 2 plus pi over 4 in order to add fractions, I need to make sure they have a common denominator. So now I'm looking at 2 pi over 4 plus pi over 4 gives us 3 pi over 4. So I know that that was a lot right there. We went through a lot of information on here. Majority of it was practice problems. Again, hopefully you were able to pause it and get some of those answers. Don't forget that you can check yourself. I see that I'm graphing a graph of sine. Here's my midline right here. I do start at the midline, so I am graphing sine. It says that it should be reflected. I do go down to a trough first, so awesome. The amplitude is 1, while the distance from the midline to a trough is 1 unit. Midline to crest is 1 unit. Period of pi from here to here is pi units, so awesome. And last but not least, a vertical shift down 1. Normally it would be on the x-axis, but I've gone down 1 unit. I believe that concludes it. Long video again, I apologize. Hopefully it did help though.